Hello everyone, this is Arnav Gupta, enrollment number 23114010, and today I am going to present my project Multi-Stage Pipeline Processor. So to understand this project, first of all, I would like to make you understand what a processor is and what is basically pipelining. So in a processor is basically CPU, and in that CPU we have 5 stages: instruction fetch, instruction decode, execute, memory access, and write back. So these are 5 stages which every instruction has to go through in order to be completely satisfied. So pipelining in this means that once an instruction is in the first, while the instruction is in the one instruction is in first stage, at the next time clock, the first instruction goes to the second stage. So the second instruction goes to the first stage. At the next time clock, the first instruction goes to the third stage. The second instruction comes in the second stage, and the third instruction comes in the first stage. This is what pipelining is, and this pipelining helps in increasing the CPU throughput. So in my project, I have made a 2 stage, a 3 stage, and a 4 stage pipeline processor. So now I will explain what a 2 stage pipeline processor, what I mean by that. So by a 2 stage pipeline processor, what I mean is that I have introduced a latch for synchronization here. So in my project, I have made two different stages in 2 stage. First stage is this fetch stage, and the second stage is this execute stage. Just a second. Second is this execute stage. Yes, this is the execute stage. So these are 2 stages, fetch and execute in a 2 stage pipeline processor. Now I will show the demonstration in a 2 staged processor. So we'll open the terminal. So as you can see, at t equals 0 nanoseconds, instruction fetch has nothing. The register R1 and R2 are initialized to value 0. Now I would like to simultaneously open the instruction memory. So every CPU instruction, like this is an instruction which asks us to move the value 5 in the register R1. So this is encoded in 32-bit binary as this binary representation. So this is the binary representation of this instruction. And for this is the second instruction which says R2 has to get the value 1. So move the value 1 in register R2, and this is the binary representation of the second instruction. Similarly, this instruction asks us to multiply R1 and R2 and store the result in R2, and this is the binary representation of the third instruction. So in this pipeline processor, as you can see, instruction fetch at t equals 0 nanoseconds, instruction fetch has no instruction. R1 has 0, value 0, and R2 has value 0, which are initialized. At t equals 10 nanoseconds, the first instruction enters into the instruction fetch stage. So the instruction fetch counter, or basically this fetch stage, has this instruction at t equals 10 nanoseconds, and R1 and R2 are still 0. At t equals 20 nanoseconds, that is at the next time clock, this second instruction comes in the instruction fetch stage, and while the first instruction gets executed. So as soon as the first instruction gets executed, R1 gets the value 5 as it is visible here. So now R1 gets the value 5, and at the next time clock, the second instruction gets executed. So R2 gets the value 1, while the third instruction, that is multiplication instruction, comes in the instruction fetch stage. So this is well demonstrated, the 2-stage pipeline. Now I will go to explain the 3-stage pipeline. So in this 3-stage pipeline, I have introduced two latches. Yes. So these are the two latches that I have introduced. One is the fetch decode latch, and other is the decode execute latch. So in this, what will happen? The first instruction would be in the fetch stage. Then after at next time clock, the first instruction would be in the second stage, and the second instruction would be in the first stage. And after that, the first instruction would be in the execute stage, second in the decode, and the third instruction would be in the fetch stage. Now I will demonstrate this again in my 3-stage. So as you can see, in 2-stage, I have this latch fetch execute. Now when I open the 3-staged processor, in 3-stage processor, I have this latch fetch decode, which is the first latch, and latch decode execute, which is the second latch. So now I will demonstrate its working. So as you can see that this is the demonstration of 3-stage pipeline processor. In this, what is happening? Again, I will open the instruction memory. So as you can see, this is the first instruction. These are the same instruction which I have already described. So at t equals 0, the first instruction is in the instruction fetch stage, which is the first instruction of this, and both the registers have 0 value. At t equals 10 nanoseconds, now the first instruction will go in the decode phase. So the register values would still be 0. Then at t equals 3, at t equals 20 nanoseconds, that is at the third time clock, the first instruction would go in the execute phase. So the first instruction is executed, R1 has the value 5, while the second instruction is in the decode phase. So this instruction is now in the decode phase, which is the second instruction, and the third instruction is in the instruction fetch stage. So this is the third instruction of multiplication. At next time clock, R2 should get the value 1, and this is indicated here. So this is well demonstrated as a 3-stage pipeline processor. Now I will illustrate what a 4-staged pipeline processor is. Now in a 4-staged pipeline processor, I have introduced 3 latches. So this is the 4-staged pipeline processor. In this, there are 3 latches: a fetch decode latch and decode execute latch, just like the previous one. And there is another latch, which is the execute and memory latch. So here what is happening is that in the t equals 0 nanoseconds, the first instruction is in the fetch stage. Then at the next time clock, the first instruction is in second, then third, then fourth. And meanwhile, the second instruction, while the first is in decode, second is in fetch. When the first is in execute, second is in decode, third is in fetch. So this is what is happening. Now I will show this. Yes, so this is the 4-staged processor, and these are its component files. And now you can see there are 3 latches: latch, fetch decode, decode execute, and execute memory. So these 3 latches are the ones which I have described just now. Now this is the output for 4-stage. Now at t equals 0, the first instruction, that is move R15, this instruction is in the instruction fetch stage. And then at the next time clock, the first instruction is in the decode phase. Then at next time clock, the first instruction is in the execute phase. And at the next, that is at t equals 30 nanoseconds, which is the 4th clock, the first instruction gets finally executed and has memory access. Memory access is a stage which basically allows us to access the registers and other types of memory which are present in the computer. So at the 4th stage, finally the first instruction is satisfied, and R1 gets the value 5. So this means, and by this time, at every subsequent time interval, the next subsequent instructions are getting fetched. So at t equals 40 nanoseconds, the next instruction, that is this instruction, should show its results. And as you can see that R2 is getting the value 1. So this is how a 4-staged pipeline processor works. And basically the total aim is to increase the CPU throughput by pipelining the processes, so that one process does not have to wait for the completion of the other process. So these are the files, and this is the whole file structure. As you can see, this is the processor core, this is the memory unit, these are the register files, and these are the hazard unit. I have also handled the hazards. Hazards are something like if one instruction is in the second stage and the first instruction is in the if one instruction is in second stage while another instruction is in the first stage, so a hazard can occur if first instruction is not properly executed. These are also called race conditions, about which can be explained later. So thank you, hope you enjoyed, and have a good day.